Is time an illusion, a mere construct of the human mind, or is it a tangible, measurable reality? This question has puzzled thinkers from all walks of life for centuries, leading to a myriad of theories and interpretations, each more intriguing than the last. Picture this, if you will. A man named Michel Siffre, isolated in a subterranean cave, devoid of any hints of the passing hours or days. No sunlight to mark the dawn, no moonlight to signify the night. His mission? To live in this timeless void for 2 whole months, with nothing but his mind to dictate the rhythm of his existence. This was no plot of a science fiction novel, but a real-life experiment conducted in the year 1962. Siffre emerged from his seclusion with a profound realization. Time, as we understand it, is not a constant flow. His internal clock had deviated from the 24-hour cycle, waking and sleeping in stretches as long as 52 hours. This experiment challenged our conventional understanding of time, suggesting that it is not an external entity we live by, but rather a psychological construct our brains adhere to. So, if our perception of time can be so drastically altered by mere isolation, what else? Don't we know about this enigmatic concept? Could time be subjective? Is it linear or cyclical? Does it operate in a block universe where past, present, and future coexist simultaneously? These are the questions that have fueled countless debates among physicists, neuroscientists, psychologists, and philosophers alike. This video aims to explore the fascinating concept of time, from personal experiences to philosophical implications. We will delve into the depths of human understanding, questioning our perceptions, and unraveling the mysteries of time. We invite you to join us on this journey as we embark on a quest to comprehend one of the most profound enigmas of the cosmos. Time. Imagine being isolated from the world, with no sense of day or night. How would you perceive time then? This is the question that French geologist Michel Siffre pondered. His curiosity led him to embark on a journey that would challenge our conventional understanding of time as a constant flow. In the depths of a subterranean cave, Siffre spent 2 months in complete isolation. No sunlight to mark the day, no moonlight to signal the night, no clocks or calendars to track the passing of time. It was just Siffre and his thoughts, in a world devoid of any external cues of time. As the days passed, or what he thought were days, Siffre began to notice a shift in his perception of time. Hours seemed like minutes, and days felt like mere hours. He was experiencing time dilation, a phenomenon where the passage of time appears to be different depending on one's frame of reference. Siffre's experiment was a testament to the power of the human brain. In the absence of external cues, his mind began to construct its own rhythm. It made its own time, independent of the world outside the cave. This was a stark revelation that suggested something profound about the nature of time. It is not an objective reality that flows uniformly for everyone, everywhere. Instead, it is a subjective experience, intricately woven by our brain. Yet, the brain is not infallible. Siffre's perception of time was not accurate. When he finally emerged from the cave, believing he had been underground for about 30 days, he was astonished to find that 2 months had passed. It was a stark reminder that while our brain constructs our perception of time, it can easily be fooled. Siffre's cave experiment laid the groundwork for future research on time perception, and it challenges us to question our own understanding of time. It invites us to ponder. If time can be so drastically distorted in the isolation of a cave, how does it shift and bend in our everyday lives, shaped by countless external cues and internal processes? So what is time? Is it a constant, unchanging flow, as we've been taught to believe? Or is it a flexible, subjective experience, crafted by our brain? The answer, it seems, is not as straightforward as we might think. Our brain, it seems, constructs the perception of time independently of external cues, suggesting time's subjective nature. What if I told you that past, present, and future coexist simultaneously? It may sound like the premise of a sci-fi movie, but it's actually a key idea in the special theory of relativity and the block universe theory. Let's start with the special theory of relativity, the brainchild of Albert Einstein. In essence, it tells us that the laws of physics are the same for all observers, no matter their state of motion, and that the speed of light is constant in a vacuum. What does this have to do with time, you may ask? Well, one of the fascinating implications of this theory is time dilation. Simply put, time can slow down or speed up, depending on the speed of the observer. If you were moving at close to the speed of light, time would appear to slow down for you compared to someone who is stationary. This challenges our conventional understanding of time as a linear, unchanging entity. Now let's move on to the block universe theory. This theory suggests that the universe is a four-dimensional block where time, like space, is just another dimension. In this block, all events that have occurred, are occurring, or will occur, are equally real and exist simultaneously. It's like a cosmic loaf of bread, where each slice represents a different moment in time. But all the slices, from the first to the last, exist at once. This concept radically challenges our perception of time as a linear flow from past to future. So, where does this leave us? It's important to remember that these theories are not meant to invalidate our everyday experience of time. After all, we still age, remember the past, and plan for the future. But they do suggest that our experience of time might not be as straightforward as we think. In fact, what we perceive as the flow of time could be an illusion, a construct of our brains. Our brains process information from our senses and create a narrative of our experiences. And part of that narrative is the sensation of time passing, of moving from one moment to the next. But if the block universe theory is correct, then all those moments exist simultaneously, and our sense of moving through time is just that: a sense, a perception, an illusion. Our experience of time's flow might be an illusion crafted by our brains. This is a challenging idea, but it's also a fascinating one, a reminder of the enigma that is time and the mysteries yet to be explored. Does our brain link space and time? A question that brings us to the fascinating concept of the Kappa effect. In the realm of psychology and neuroscience, the Kappa effect is a curious phenomenon that demonstrates how our perception of time can be influenced by our perception of space. The Kappa effect is essentially a cognitive illusion, where the duration between two events seems longer if the spatial distance between them is increased. Imagine, for example, you're traveling from point A to point B, and then to point C. If the distance between B and C is greater than the distance between A and B, you might perceive that the journey from B to C takes more time, even if the time taken for both journeys is exactly the same. This is the Kappa effect in action. This intriguing effect underscores the deep-seated connection between spatial and temporal processing in our brains. It suggests that our perception of time is not an isolated construct, but is deeply intertwined with our perception of space. Our brains, it seems, are hardwired to link space and time together, creating a unified perception of our reality. But what does this mean for our understanding of time? Well, it adds another layer to the complex tapestry of time perception. It suggests that our experience of time is subjective, influenced not just by internal factors like our state of mind or our level of attention, but also by external factors like the physical space around us. The Kappa effect brings us one step closer to understanding the enigma of time perception. It provides a fascinating insight into how our brains construct our reality, highlighting the intricate interplay between our perception of space and time. And it leaves us with the tantalizing possibility that our perception of time might be more flexible and malleable than we previously thought. So, as we delve deeper into the mysteries of time, let's not forget the role of space. For as the Kappa effect shows us, our perception of time might be intertwined with our perception of space. Does the block universe theory imply that our future is predestined? This question is our starting point as we delve into the philosophical implications of the block universe for concepts like free will and predestination. The block universe theory presents a universe where past, present, and future coexist simultaneously. It's like a cosmic loaf of bread, with every slice representing a different point in time. If this theory holds true, then every event, every choice, and every outcome is already set in stone. This idea seems to contradict our deeply ingrained belief in free will, the idea that we have the power to shape our destinies through the choices we make. So, where does this leave us? Are we merely actors playing out roles that have been pre-written in the cosmic script? Or are we active participants, capable of changing the course of our lives? To answer these questions, let's examine two opposing philosophical views: determinism and indeterminism. Determinism is the belief that every event, including human cognition and behavior, decision and action, is causally determined by an unbroken chain of prior occurrences. It's like a row of dominoes. Once the first one falls, the subsequent course of events is inevitable. In this view, free will is an illusion, because every action we take is just the result of prior causes. On the other hand, indeterminism suggests that not all events are predetermined. It allows for the possibility of randomness or chance occurrences. This view seems to leave room for free will, as it implies that our choices can genuinely influence the course of events. However, neither deterministic nor indeterministic models of the universe seem to provide a satisfactory explanation for our experience of free will. It's a paradox that continues to baffle scientists and philosophers alike. Some philosophers propose a middle ground with compatibilism. This view suggests that determinism and free will are not mutually exclusive. It argues that our choices can be both causally determined by past events and free, as long as they stem from our own desires and intentions. In the end, the block universe theory doesn't provide definitive answers about free will and predestination. It's a perspective that challenges our intuitive understanding of time and causality. It invites us to question our assumptions and consider new possibilities. Perhaps our intuitive sense of temporal flow is at odds with scientific theories. But isn't that what makes the exploration of time so fascinating? The tension between what we intuitively feel and what science proposes pushes us to probe deeper into the mysteries of the universe. It's a thought-provoking journey that continues to unfold, one slice of cosmic bread at a time. What is the present, according to Einstein? This question opens a Pandora's box of philosophical and scientific conundrums. Einstein, the architect of the theory of relativity, found himself perplexed by the concept of now, or the present. In Einstein's universe, where space and time are intricately woven into a four-dimensional fabric, the idea of a universal now, or present, simply doesn't fit. For Einstein, simultaneity is relative, depending on the observer's frame of reference. This throws our conventional understanding of the present into disarray. What you and I perceive as happening now could be vastly different based on our relative positions and motions. This paradox troubled Einstein, as it contrasted sharply with our intuitive, subjective experience of now. This leads us to an intriguing question. Is our perception of time's passage merely a mental construct with no physical counterpart? Contemporary philosophers and cognitive scientists have been wrestling with this question, and some compelling perspectives have emerged. One such perspective posits that our sense of time's passage, our experience of now, is a product of our consciousness. It's a cognitive process that helps us make sense of our experiences and the world around us. It's not that time doesn't exist, but our subjective experience of it, the feeling of time flowing from the past into the future, might be an illusion, a trick of the mind. Another perspective draws upon quantum mechanics, suggesting that the universe at its fundamental level doesn't distinguish between past, present, and future. These are categories we impose on reality to navigate our existence. This perspective aligns with Einstein's block universe, where all moments coexist simultaneously. These perspectives, while radical and counterintuitive, offer fascinating insights into the nature of time and our experience of it. They challenge our deeply ingrained beliefs and invite us to reconsider our understanding of reality. So, where does this leave us? If our perception of time's passage is just a mental construct, does it mean that the present is an illusion? Perhaps. It's a thought-provoking idea that shakes our conventional notions of time. It suggests that our experience of time might not have a physical counterpart in the universe. Is time a tangible reality or a mere illusion? This is the profound question we've been grappling with. From personal experiences of time dilation, like Michel Siffre's daring cave experiment, to the grand theories of relativity and the block universe, we've seen that time is far from the simple linear concept we once thought it to be. Our journey has shown us that the human brain is a master of time, capable of crafting its perception independent of external cues. We've learned of the Kappa effect, the brain's inherent tendency to intertwine space and time. And we've seen how this connection runs so deep, it's embedded even in our language and thought processes. We've contemplated the philosophical implications of a universe where past, present, and future coexist, a perspective that shakes the very foundation of concepts like free will and predestination. Our understanding of the present, as Einstein himself grappled with, is fraught with complexities and contradictions. We've also delved into contemporary philosophical perspectives, which suggest that our experience of time's passage may be a mental construct with no physical counterpart. Could it be that what we perceive as the flow of time is just an illusion, a masterpiece crafted by the human brain? Navigating the enigma of time is like walking a tightrope, balancing our subjective experiences with the objective framework offered by physics. It's a challenge, a puzzle, and yet, it's this very complexity that makes the exploration of time so fascinating, so engaging. As we stand at the intersection of physics, neuroscience, psychology, and philosophy, we realize that understanding time is not a solitary pursuit, but a shared human endeavor. We are all time travelers, journeying together in the quest for knowledge. So let's continue to explore, to question, to ponder. The journey to unravel time's deeper truths is an ongoing, shared human endeavor. What does the future hold for our understanding of time? As we stand on the precipice of the unknown, the answer to this question is as elusive as time itself. Yet, the quest for knowledge is unending, fueled by our innate curiosity and a thirst for understanding. Our journey so far has led us to fascinating insights. From the strange ways our brain perceives time to the mind-boggling implications of relativity theory. We've seen that time, once considered a constant flow, may be more accurately compared to a block universe, with past, present, and future coexisting simultaneously. We've grappled with the profound tension between our linear perception of time and the concepts of free will and predestination. Yet, for all we've learned, the enigma of time remains largely intact. It dances just beyond our grasp, teasing us with tantalizing glimpses of understanding, only to slip away in the face of our attempts to pin it down. But do not despair. In the face of the cosmos' profound and enigmatic nature, our wonder and curiosity are our greatest assets. They push us to question, to explore, to seek out the deeper truths that lie beneath the surface of our everyday understanding. And so, as we look to the future, we do so with a sense of eager anticipation. Each new discovery, each shift in our understanding, brings us one step closer to unraveling the enigma of time. The journey may be long and fraught with complexities, but it is a journey we undertake together as a shared human endeavor. So, let us continue to ponder the mysteries of time. Let us remain open-minded and inquisitive, embracing the enigmatic nature of the cosmos. For it is in this spirit of exploration and discovery that we will find our path forward. As we delve deeper into the cosmos, we continue to unravel the profound mysteries of time.